Hi everyone, it's noon now, so we're gonna go ahead and get started.
Okay. So, hello everybody. My name is Catherine Russell. I'll be your moderator for today. I am the Greenhouse Floriculture Production Specialist with the Ontario Ministry of Agriculture, Food and Agribusiness. Our topic for today's webinar, super important right now, a lot of growers are dealing with this, the road to Thrips parvispinus control. This is a GrowON webinar, part of our GrowON educational series here at OMAFA. Um, and we don't just do webinars, we also do in-person events like Lunch and Learns. And we don't only cover IPM topics, we also cover production topics such as greenhouse environment, nutrient management, media, other production things like that. If you missed something today while Sarah's talking, don't be worried because we will be posting the recording on the On Floriculture YouTube page. And once I'm done my little spiel here, I will post that in the chat for you to visit. We really encourage questions in this webinar. So if you'd like to ask a question, please drop it in the Q&A function, and we'll get to that at the end of the webinar. And we'll start off with a quick land acknowledgement here. Um, the Niagara region is situated on treaty land. This land is steeped in the rich history of the First Nations, such as the Hattie-Wendoronk, the Haudenosaunee, and the Anishinaabe, including the Mississaugas of the Credit First Nation. There are many First Nations, Métis, and Inuit from across Turtle Island that live and work in Niagara today. The regional municipality of Niagara stands with all Indigenous peoples, past and present, in promoting the wise stewardship of land on the lands of which we live. I'm so excited to introduce our speaker today, a super familiar face to many of you, Dr. Sarah Jandrisic. She is my counterpart here at OMAFA. She is the Greenhouse Floriculture IPM Specialist. She's going to be talking about Thrips parvispinus control. There's a lot of different information coming out right now. It can be difficult for growers to sift through. She's going to give you some information so that you can critically evaluate that information and help incorporate it into your IPM in your own greenhouse. Without further ado, Sarah, take it away.
Thank you so much, Catherine. Okay, I'm going to share my screen and hope everything goes well. I swear, after all this time of doing webinars, it's still nerve-wracking sometimes when technology doesn't go right. So, okay, good. We've got my title page, so one thing's going right. All right. So as Catherine mentioned, this is going to be a lot of information. So on my On Floriculture blog, I like to make sure you can sort of look up anything I've talked about to make sure it's in more than one place. So we've got a whole page dedicated to parvispinus resources, as well as our GrowON webinars are all recorded and then posted on this page from the YouTube channel as well. And if you are not subscribed, I encourage you to subscribe to the blog. And we send out about 2 posts a month, sometimes 3 or 4, depending on what's happening out there. And it gives you all the latest IPM information and production information related to floriculture. So as Catherine mentioned, some of my goals today are to share some of the new biocontrol research that's been coming out. Parvispinus has been a pest in North America for about 5 years now, which is pretty much a research like grant cycle. So when it first came on scene, it takes a while for researchers to get money to actually start researching thing, and it's more the boots on the ground people like myself and extension agents in Florida who really have to sort of do their best to figure out what's going on until then. But now that the researchers have money and things that are happening, there's lots of information coming out. So I'm going to summarize some of that for you. We're also going to touch on where we are now in terms of pesticide programs, as well as where we're going. But the most important thing I want you to take away from this webinar that Catherine mentioned is critical thinking about the research that's coming out. In other words, how do we evaluate the claims and the research updates that are coming out? So I'm going to explain to you a bit about the different kinds of experiments scientists do. and then sort of like the weighting of those. Because the information really is coming out of as a fire hose rate. And it would be really tempting to try a lot of things in your greenhouse now. Um, but when you sort of can't evaluate which thing to try, you can end up wasting a lot of time and labor and money going into different biocontrol agents and things like that. And just to note that I'm talking more from a northern perspective in terms of greenhouses where we're getting in the parvi from imported material. And then we only have the parvispinus population that's within our greenhouse to deal with. We don't have new ones flying in from outside, which obviously complicates everything. Um, so just be aware of that, that this may not apply to everyone, especially if you have parvispinus populations outside. So you might have noticed that some of the focus of this talk is obviously focused on biocontrol research for parvispinus. So why biocontrol when we do have effective pesticides for parvi right now? Well, first of all, the pesticides are working, but they're not perfect. Um, and the bigger issue is resistance is always a potential. And here in Canada, we have seen resistance to both ferrets, which I believe is known as mainspring in the States, as well as success, which is known as conserve in the States. Um, and we really don't have a lot of chemicals that work on both the adults and the larvae of parvispinus. So that's one reason to start looking at biocontrol. And then another issue that my growers have really struggled with is a resurgence of other pests. So things like two-spotted spider mite, which used to be really well controlled in Mandevilla with Persimilis and predatory mites like that, as well as things like whitefly and hibiscus. These have really come back tenfold because with all the spraying we're doing for parvispinus, we can't have biocontrol measures for these secondary pests anymore. So this is another reason why we need to look into sort of a comprehensive program for not just parvispinus, but these other pests that occur in the same crops. So we're going to start with where everything starts, which is in propagation. So the first sort of new information that might be out there that you guys might have missed is the host list. This is the host list in the table that I've had up on the blog for a while. But talking with growers in the region, the host list has really expanded this year. And I think this is just because we've had parvispinus in our greenhouses for longer. So now the thrips are like, ooh, what else can I eat? And they started booping over to different crops and then establishing on those. So the big one I would say is we've seen them in both cut and potted Lysianthus, and they really seem to enjoy the pollen in those flower heads. Also euphorbia. I've worked with a grower where we had a lot of difficulty controlling these with pesticides. Um, and also the other interesting one is weed hosts. In an anthurium greenhouse, we found them really happily on the weeds, and just outside the greenhouse, another grower found them on the weeds as well. So even if you have a spray program, if you're not controlling your weeds, they might be going outside the greenhouse, living in the weeds right outside your vents, and then coming back in. So that's something to think about. So that's why we always sort of keep a tab on the host populations. So for those in northern greenhouses, we have confirmed by surveying cuttings. This is work I've done in collaboration with the Vineland Research and Innovation Center. We have a big grant on parvispinus. So we did a survey of Mandevilla cuttings last year where we brought in different cuttings, bags of cuttings on different weeks, and you can see different varieties. And we confirmed that the parvispinus were coming in on those cuttings, and we haven't found any other source, like they can't blow up here from winds or anything like that. So it's primarily the propagative material we're importing. So what does that mean in terms of control? It means that the cutting material or propagative material is going to be one of your main targets to have an effective IPM program for this pest. And research from both the Vineland Research Station here in Ontario, as well as Alexandria Ravinthi's lab in Florida, have concurred on this. And they've both done dipping experiments to look at either survival of the larvae and adults after dipping in these materials. That's the Vineland graph. So lower is better when we talk about survival. And then Alexandra's lab did mortality, which is the reverse of the survival. So you want to look for the bigger bar. And both of them concur that Suffoil X is one of the best materials to dip your imported cuttings on to reduce parvi levels. And this, depending on the study, can reduce incoming parvi by anywhere from around 50 to 70%. It both washes off the larvae and adults that are there and also kills those remaining. And we have done phyto tests because that's always a concern growers come to me with is like, can I dip? and not have phytotoxicity happen. So we have tested phyto on mandevilla, anthurium, and hibiscus, and really had very little. Subfoil X at the 0.1% rate has been very safe. It's only if you go to higher rates or some of the microbial formulations that we often dip in. The WP formulations don't look that effective. The ones that are more effective are the ones that have some oil in them, so the liquid formulations. But some of these can cause phyto. And you may be asking which ones? Well, you'll have to come to the Canadian Greenhouse Conference this fall. It's in about 2 weeks from now in October. The Boughton House Lab is going to be sharing their dip information there. But for now, you can use Suffoil, and then I'll have more information in the future after CGC on if you want to try microbials instead. So we're going to move on from dips and talk about microbials, because now we're going to talk about, are there any biocontrol agents that are effective for parvispinus? So before I get into the nitty-gritty, this is where I want to explain the different kinds of studies that that researchers do. Some of these are done with growers, but that's later in the process. So that you can really understand what the point of these tests are, the pros and cons, and sort of how much weight to put behind them. So the first thing we pretty much always do is lab trials. And these are usually done in little dishes with only like 10 insects. And so we can do like predation trials in here. We put some thrips in and then put a mite in, for example, or this would be an example where we put 10 parvi in and spray them with a pesticide and see how many of those 10 are dead. So we get the percentage mortality rates of pesticides and things like that. So the benefit of this kind of lab trial is, of course, it can get us really quick answers. We can get really high replicates, meaning we can do this a bunch of times, which means we have more confidence in the data. And the reason we do this is to provide research direction, because if it doesn't work in the lab in this sort of worst case scenario or best case scenario, depending on what you're testing, if it doesn't work in this worst case scenario trial, then it pretty much is guaranteed not to work on a whole plant or in the greenhouse. But if it does work in this worst case scenario, um, that means we should go forward and test it more, but it might not work when you get into like whole plants when, things like plant architecture and humidity and things are going. But anyway, we need a way to sort of weed out the no's, and that's what we're doing here. So, and like I sort of mentioned, it can be a very artificial research environment. The insects can't escape. Temperature and relative humidity are very controlled, and it doesn't always reflect what happens in those cage trials afterwards. But it gives us a place to start. So think of it like a screening trial. So then we usually work up to small cage trials, and these can either be cages over individual plants, or you can have like larger, usually what we call bug dorms or tents, where we put anywhere from like 4 to 12 plants in. So the pros of these are it actually allows the insects to move not only between plants, but within plants. And we know insects like different parts of plants. Thrips really like growing points and flowers and things like that. So that's an important consideration when we're testing both biologicals and pesticides when it comes to things like coverage. And they are easier to replicate than, larger greenhouse trials, although they're more obviously work than plant trials. The cons of this are that you can only do so many plants. There's only so much room in research greenhouses. The cages themselves can affect temperature and relative humidity, which can affect things. And it does still limit migration, compared to an actual greenhouse. So then usually what researchers scale up to is they'll either do a large cage trial, which would be like half a bench or something, or even an open bench experiment. This is actually work from my PhD, where we at least let the insects choose where they wanted to be in terms of attraction and migration and things like that. So again, a more realistic setup while still providing the researcher with some control. Potentially you could have another research compartment where you've got a control treatment or an industry standard to compare your new treatment to. But again, they don't capture all the factors that you would find on a farm, like workflow and differences in sprayers doing different applications. But it's obviously harder to repeat. These cost a lot of money in terms of research space and people's time. So we can't do a lot of these. And then lastly, what I mostly do, I have the privilege of doing, is on-farm trials with growers. So these are growers trusting me with their crops. And this lets me test things under real world conditions. And we're actually working with the grower to figure out the logistics. Like, is this economical? Is this feasible? Like, do your workers have the space and time to do what I'm asking you to do? And it also considers the effects of other pests. So just because we're doing a control program for parvispinus, are we going to get oleander aphid? Are we going to get spider mite? Like, what else is going to happen? The negatives, though, are that it's usually difficult for us to have a true control treatment to compare against, which is sort of the gold standard in science. Because funnily enough, growers don't love it when you have a part of their greenhouse where you're like, we're going to introduce pests and then, just let them go crazy and it's probably going to destroy your crop. So often what we do is we compare to an industry standard. So that would be, in the case of parvispinus, we might compare a pesticide spray program to a microbial program to a biocontrol program, something like that, with the pesticides being the industry standard. And generally, we do have less control as researchers. Sometimes as a researcher, it can be frustrating to go in and do an experiment and the plants have been sold or moved or your sticky cards are on the ground or things like that. So that is not always possible. But in the terms of ranking these, I want you to put sort of be curious about lab trials and realize those may hint at the future, but not really put all your weight into them. And then cage trials would be a little bit better. And then from a research perspective, open venture large cage experiments are sort of the best we're really going to do. And if there's an on-farm trial, well, that's just icing on the cake. And then the only other caveat about on-farm trials is you may think, oh, well, those are the only ones I will trust. But again, they're hard to do with growers. And then we all live in this reality where what happens on your farm may not work at someone else's farm because of a lot of factors like again, the crops you grow, the way your greenhouse is laid out, like your staff, things like that. So what we're working towards right now is these large cage or greenhouse, research greenhouse experiments. So just keep all of this in mind when we go forward and talk about some of the different bios that are out there. So in terms of microbials, two big studies have been done so far. There's probably lots more research out there. It's even hard for me to keep on top of this, but let's compare some studies that I do have my hands on. So one's from the University of Florida, and then a trial came out from Anthuria working with Copert on anthuriums. So the trial from Florida is a true lab trial, so probably using those little petri dishes and a spray tower. So again, with lab versus cage trials, you also kind of need to figure out what the goal of the trial was. So for this lab trial, they're doing a spray test, like a screening test to see what microbials work. So they really were asking, did this spray kill the parvispinus after one spray? And then they looked at adults and larvae. But then when you're talking about a cage trial, sure, you're interested in the number of parvispinus on each plant in each treatment. That is relevant. But what's more relevant is damage over time, because you can potentially have a cage that's got quite a few thrips on it, but the plants look pretty good, like they would be able to be sold. And the opposite can be true, right? Like when we're working with mandevilla, you can tap out a mandevilla plant, have only one or two thrips fall out. You're thinking to yourself, oh, this looks really good. But the mandevillas still aren't growing because on a mandevilla, one or two parvispinus just aren't going to work out. So damage can be an important metric. So that's one place these two trials differ. If we actually look at the products now, so if we compare Bovaria-based microbials, so these are things like Botaniguard WP or Bioceres WP, you can see that both the lab and the cage trial concurred in this cage, and they both concurred that it was not very effective. So in the University of Florida stuff, you don't see a lot of plus signs, which is their indication that it's working. And over here in the Copert trial, if you look at the untreated control, we obviously want a better result than that because they're giving it a damage rating of 4.5 out of a possible 5 being the worst. And you can see the Botaniguard is also a 5, so that's not great. So the next set of things they tested were Eiseria, which is another genus of microbials like Bovaria or Metarhizium. And in the Florida trial, the Eiserias did pretty good, which is really exciting and promising because that's sort of a new microbial for us in terms of the greenhouse world up here anyway. But unfortunately, in the cage trial, not that great. And then again, what about the Bovarias in liquid form? So like the ES or the EC formulations. Again, some of them in the Florida trial didn't look that great, but Velifer looked pretty promising. But then Velifer over in the cage trial, again, no difference in the untreated control. So because these basically confirm each other, right now, I would trust this information and, suggest that maybe there might be some hope for some of the Eiserias or maybe one of the Botanigards or sorry, Bovarias going forward, but I'm going to need more cage trials to prove that. And then lastly, Lalgard M52 is the other one that was tested in the lab, but there's no cage trial, but they got really good results in the lab. So then we need to ask ourselves, is there any more information out there? And luckily, there are on-farm trials from this one. So this is work that I did with some summer students with a grower collaborator. This was a mandevilla crop in 2023. This is one of those trials where we were throwing everything at the wall. So like, just throwing the spaghetti on and see what sticks. So at the beginning of the production period, we did what we tried call to program the economical rates of bios. So we did a lot of big bios. And then we also, as our main spray, did weekly applications of a wettable powder of a Bovaria product. And it's not important which one that is right now, especially because, as you can see, it really did not work. And we went from, fairly steady rates of parvispinus at around 5 parvispinus per plant. And this skyrocketed in the summer up to 85 thrips per plant on this one very susceptible variety. So we went in and we tried to rescue this with also biocontrol. So here we released some anistis mites, and I'll talk more about them later. But the main thing we used was M52 as like a sprench 3 times. And you can see this brought down the thrips numbers really, really well. And then we just had to spray this white variety that was really susceptible and sort of like feeding the thrips into the other varieties. And basically we got this down to baseline levels, and I was very, very happy with it. So this sort of tells me that M52 is a good product because we saw it work in the field and there's lab trials to back that up. Okay, so what about other microbials? So you can also consider nematodes, entomopathogenic nematodes, as microbials, mostly because they carry a bacteria inside them that is actually what kills the thrips. So we're all used to Steinernema feltii being our typical nematode for thrips and fungus gnat control, and that's been our good old standby. But what Alexander Ravinthy's lab found at Florida was that this in the lab trials basically did nothing, so it wasn't even worth continuing testing. Again, that's why we do the screening trials in the lab, so then we can decide what's worth doing on whole plants or in cage trials. So then they did these trials on whole plants, looking at how many pupae actually emerged of parvispinus. And you can see that Steinernema carpocapsae, another nematode species, actually did the best at suppressing parvispinus. So they had a 53% reduction in the adults emerging. So because this was a cage trial, I have a lot more faith in this. And again, they sort of did this in isolation in terms of like what percentage control is this one component of an IPM program giving us. They didn't assess it with other IPM programs or like other components or assess damage, but just by itself, that's a huge reduction. And I thought you would all like to see the face of a nematode, which to haunt your dreams. We see a lot of just like squiggly lines as nematodes a lot. So I just thought you'd like to see what they look like close up because they're kind of horrifying. But great. So just in summary of this section, as I mentioned, M52 has really good lab and greenhouse results. And this is not just things that I've seen working with growers, but other industry reps. So for example, Judy Colley from Plant Products has worked with other growers and seen really good results with this. And I would say there's probably other microbials out there that are going to be effective, but we really need to test these in cage trials. And again, nematodes had really good results in cage trials, but we're going to have to switch the species we're using from feltii to carpocapsae. And then just throughout this throughout this talk, I'm going to be asking you to, be excited, be hopeful, but also temper your expectations. Neither one of these on their own is likely going to offer control, or we probably would have great biocontrol by now, but they're going to be an important part of like a well-rounded biocontrol or IPM program. So the next thing I'm going to talk about are big bios for parvispinus, and then I'll get into some of the smaller bios like mites. So in terms of the big bios, there's several large bios in screening programs that we know will eat parvispinus, and that's Dalodia coriaria, different murids, so things like Dicyphus or Macrolophus. I'm going to call Anistis, which is the crazy mite, a big bio because it just acts so different than the little phytoceid mites we're used to using. So it's big, so it's in the big bios. And also lacewings and aureus. So yeah, sure, they'll eat stuff, but how promising are they? So we're going to focus on aureus. This is some of the lab trials that came out of University of Florida, and they do have a webinar up right now detailing more of their information coming out of their lab with the big bios. So Catherine's going to put a link into their lab page where any of their webinars will go up. And I know they just did a big sort of all day webinar extravaganza from like 8 a.m. to like 2 p.m. Last week. So there should be lots of good details in there. But just this snapshot of one of their trials, you can see that Aureus eats anywhere from 20 to 25 L2 larvae or adult parvispinus in 24 hours. So that's a great predation rate. We also have some cage trials we're working on here in Ontario that are showing some similar things. And we've also seen really good results on farm with these guys. So again, lab trials on their own, maybe that's not enough to convince you, but we've got some cage trials and on-farm trials that have shown success. So one of these examples is an on-farm trial done by Judy Colley of plant products up here in Ontario with anthuriums. And initially, they found that they needed really high rates of Aureus, so 1 Aureus per square foot, to actually get an effect for 6 weeks, and then they could drop it down a bit. But that was still not economical enough for the grower to do long term. So then Judy was able to figure out that if they sprayed the incoming propagative material with success in M52 at receipt, and then after a few weeks to let those pesticide residuals dissipate, then they were able to add the Aureus, so they could drop that to 0.25 of an Aureus per square foot. So this program was really successful for over a year. Um, Unfortunately, it stopped working due to suspected pesticide residues on the incoming plant material. So they were obviously using more than just Success or M52, something that the Aureus really couldn't tolerate. So unfortunately, this greenhouse is back to a chemical spray program. And I would say the other caveat is this really only worked on the more tolerant varieties of anthuriums. There's a light purple variety that just gets hammered. So the grower had to do some cultural controls as well and change their varieties. And we can talk a little bit more about that later. And in terms of my own work on Mandevilla, we also did another biocontrol program looking at really high rates of Aureus, lacewing, and Atheta in 9-inch Mandevilla in 2023. And I won't even go into the rates because they were not economical, but it was just trying to be like, okay, if we like blast these with the big bios, will we get control? And you can see the numbers really do go down. And ultimately, after several weeks of releases, we had the thrips numbers down to under 1 per plant on a 9-inch pot, which sounds really exciting. But unfortunately, it was not enough to prevent damage. So those little trellising growing points of the mandevilla, if they don't grow, the whole, your plant isn't growing, and you basically won't have a mandevilla crop in time. So unfortunately, even though we were only tapping out really low numbers, it wasn't low enough. And in the course of this experiment, we also realized that the only biocontrol agent we were able to recover out of all these big ones was Aureus. So was Aureus contributing something? Absolutely. Was it enough to actually run a whole biocontrol program on and have a successful crop of mandevilla? Absolutely not. And you may be asking yourself, okay, well, why did Judy's program work and Sarah's program didn't? Well, there's just so many crop differences between anthurium and mandevilla. Obviously, architecture plays a huge role. Mandevilla, when they trellis, are huge, and it's so much area to cover. And also, I just think it comes down to their tolerance. Anthurium can handle a lot more parvispinus without looking too damaged than mandevilla can, because they just stop growing. They also get that really brown sort of scar tissue forming on the leaves. And also because they have those big trumpet flowers, you can really see the parvispinus inside, which guess what? Customers don't like very much. So I do think Aureus is likely to be an effective part of our IPM programs moving forward, and I believe it can be cost effective. But I think we're going to have to pick and choose the host that makes sense on. So maybe some more moderately susceptible hosts it'll work on, but maybe not mandevilla. The other big bio I have the most confidence in right now is anistis. Again, in lab trials in Florida, they found it can eat oodles and oodles of parvispinus, which is great. Another benefit of anistis is that compared to Aureus, it's actually pretty compatible with microbial pesticides. Aureus tends to kick the bucket when you add Bavaria or Metarhizium to it. Unlike Aureus, anistis is also pretty cold tolerant, which is important for crops like mandevilla, where over the cooler months, we're holding them closer to like 15 or 18. And anistis can handle that and is still active. So again, if you want some on-farm sort of proof of why I'm feeling positive about this, back to this graph I showed you before, where we had this explosion of parvispinus and mandevilla, but then we were able to recover it with both M52 and anistis. And I think using them together was really what saved us. And we did recover the anistis on the plants. So just back to our summary slide of all the big bios, Alexandra Vinthy's lab has also gone through most of these. And, Dicyphus is really promising, Macrolophus is promising, lacewing are promising. The only one that really didn't pan out like we expected was Delodia or Theta. It just didn't eat as many parvispinus pupae as anyone hoped. So stay tuned for more information on further cage and greenhouse trials with all these big guys. And just to summarize this part of the talk, Aureus and Anistis ate huge numbers of parvispinus, and I am cautiously optimistic about them, especially in more moderately susceptible crops. And I think they could work potentially really well with a microbial program, especially Anistis, which is more resistant to microbials, or Aureus if you sort of, time your sprays and releases right. And again, just in the, hopes of tempering expectations, though, uh, there might be cheaper bios out there that work, like green lacewing's a pretty cheap bio, but some of the information that's come out of the Netherlands shows that sure, green lacewing can work, but you might need super, super high rates. So just be aware of that. And all of this is probably going to come down to the host plant, pesticide residues, and really like the cost tolerance or economic feasibility for your particular farm. So the next thing I'm going to touch on is research with phytoseed mites. So this is things like Lamonicus, Swirsky, or Cucumerus. And I know this is the one that growers are the most curious about because we know they've done such a great job for us for Western flower thrips. They come in sachets already. Like we want them to work, and I'm there with you. I get it. Unfortunately, they're not looking the best right now, and I'll sort of walk you through why I think that is based on the data. So there are lab trials coming out right now. Again, Florida and Copert's already done some. And right now, the lab trials out of the gate are conflicting as to the best species. So Copert has found that Montardensis is probably the best, and then Lamonicus. And unfortunately, Montardensis we can't get in North America. It's a species that's staying in Europe right now. Um, University of Florida, they had a bit of different results. They found that degenerans and Swirsky ate the most. But again, these are just in cups where nobody can escape. So I'm not going to put a lot of credence in these right now, just because of the types of tests, not because everyone's not doing their best, and not because these aren't great trials for what they are. So now we have cage trials from Anthura and Copert. So again, I love a good cage trial. So in their cage trials, if you compare the mite treatments, and they also had lacewing in here, to an untreated control, and again, they're looking at the total number of thrips on the plant. So their best results were with both Montardensis and Swirsky, and they also looked at plant damage, but I didn't show that here. And they were doing supplemental feeding of both of these mites. So you can see compared to the control that had around 6 thrips per plant at the end of the experiment, the one with Montardensis basically had no recoverable thrips, and there was very few with the Swirsky treatments. That seems really exciting. Unfortunately, there is another cage trial that has come out of a University of the Netherlands, which did not find the same results with Swirsky. They basically found they didn't impact the thrips at all and were not recoverable. But the big difference is there that they didn't use supplemental food. So maybe supplemental food is going to be part of this. But what I have to also focus on here is this economically feasible? The rate they used was 6 curative introductions of 200 mites per square meter over 6 weeks. So just to let you know, this was the rate we usually reserve for hot spots of Western flower thrips control, which means it's probably not going to be economically feasible. Maybe we can use it on hot spots. We'll have to see how that works out in the wash. And then further, I just want to keep harping home the point that this might work on anthuriums or another moderately susceptible crop to parvispinus, but I don't think these are going to be translatable to Mandevilla. And the reason I think that is because myself and BioBee really tried to do some trials with predatory mites to get them to work. We did all the things. We did different species, so Cucumerus and Swirsky, we did them together. We did multiple sachets per plant. We tried weekly broadcasts, both manually and with a blower. We did with food, without food, different size pots, different times of planting, like closer to propagation and further into production. And BioBee was wonderful and donated a lot of product. And Kelly Smith, their rep at the time, put a lot of effort into seeing if she could recover the mites on the plants. And unfortunately, not only did we get huge spiking levels of parvispinus on these mandevilla, but Kelly could never recover a single mite on the mandevilla. Um, so just a caveat to this, we never tried degenerans or Lamonicus, so maybe those could work, but I would need to see both lab and some solid cage trials before I got too excited about putting these on myself. So right now, mites are in sort of the like stop and let's wait to see what else comes out. Because we really don't know what species yet. We don't know what host plants they'd like, and we don't even know, like, should we be using supplemental food or no? And is this going to be cost effective? Because remember, cucumeris is the cheapest mite, and from all the experiments out there, it doesn't look like that's going to be a go. So you're automatically going to be paying more for either Swirsky or Lamonicus. So just to summarize this sort of section on the different bios and also critical thinking, uh, I do want you to think about or ask yourself different questions before you implement something. So questions I usually ask a grower are like, who are you hearing this from and are they unbiased? Because not, I think everyone goes in with good faith, but obviously companies want to sell things. Um, but that doesn't mean they're totally biased if they've got good data and they're willing to show it to you or have you talk to another grower where it was successful, then I'm all for that. So just asking those kinds of questions and trying to get in for more information out of whoever is telling you to use what. Is there more than one study out there and do they agree? Often, if a grower is hearing it from more than one source that this will work, then I have a lot of faith in it. So if you're hearing it from a rep, but you're also hearing it from extension or research or academia, or you're hearing it from the States and you're hearing it from Canada, then I would say put more faith in it. And then if someone has tried it, and they showed you data for a study, was there a control or was there an industry standard like pesticides? They compared it to you. So you can actually see the level of control compared to spraying so that you know whether to switch or not. And then also, what crop was it on? Just because it works for someone else's anthurium crop or crotons or schefflera doesn't mean it's going to work on your mandevilla or vice versa. So how do we put this all together? All this information. Again, the fire hose of information, and we're not even at we're sort of just, the fire hose just turned on. There's going to be a lot more water coming out of it. How do we start to put all this all together? Well, definitely breaking up your growing into different sections like propagation, early production, late production helps, and thinking of all those separately. So I'm going to sort of walk you through what I've been telling some of my growers and collaborators what we should be trying early on. So starting with production, absolutely dipping. Suff oil or one of the other things that's going to come out in research soon. You're basically getting rid of 50 to 70% of your incoming Thrips parvispinus. And then based on the work out of Florida, I believe absolutely in propagation, we should be doing applications of Steinernema carpocapsae, the nematode that's shown to be a little bit better. Um, and then it's sort of a big question mark after this. Obviously, propagation is the logical place to do a lot of biocontrol. This is what we do for Western flower thrips, right? And the reason we do this is because it's more economical, it's a smaller area, and it's sort of front loading the bios and getting on top of them before you go out into production. So we did attempt to do this. Again, Kelly Smith from BioBee. And again, thank you to BioBee for donating stuff. Um, so we did try to attempt to do this where we did a biocontrols only bench. We had a microbials only bench and a pesticide standard bench. And you can see our biocontrol trial, again, throwing all the spaghetti at the wall, mainly going with aureus, but also doing some lacewing, carpocapsae, and Stratiolaps schimatus. So unfortunately, we didn't recover a single biocontrol agent from these trials in mandevilla propagation, and there's two reasons for this, I think. First of all, the temperatures are really high in propagation. Even if you don't tent your mandevilla, propagation can go over 30 degrees Celsius, and most biocontrol agents, including nematodes, really don't survive much past 30. So I'm working with crop defenders right now. They're doing some screening trials with different nematode species in Mandevilla crops to see if we can actually recover the nematodes and make sure they're fine. But we know the big bios and the mites on the foliage like did not survive. And then the other thing that happened was we actually took these cuttings back to the lab when we couldn't find anything on them and looked at pesticide residues. And you can see there were a lot of different chemicals that pinged in these residue tests. They were fairly low, like under 4 ppm, but there was a lot of them. And if you look in the literature to look at what sort of rates of residuals affect biocontrol agents, for aureus, it can be somewhere like 30 or 40 ppm. So this is obviously a lot lower to that. But exposure to a lot of small doses of chemicals can still have an effect on you. So I suspect that plus the heat was not great for anyone. So obviously pesticide residues are things that are going to affect our ability to do biocontrol in propagation in the future for any crop really. So for now in propagation, I would really just stick to the dips and the applications of carpocapsy and even adding stratiolate to the soil because they're relatively inexpensive. But at this point, big bios and even microbials are not going to survive past 30 degrees Celsius. Okay, so what about production? And this is where I'm going to focus a bit more on pesticides. And one thing that came out of the recent work from Florida that I thought was a really good illustration was the difference in lab trials versus whole plant trials with pesticides. So just quickly, the green bars were their Florida's results with lab trials with different chemicals, and then the blue bars underneath are their success on whole plants. And you can see with both success and expire, they went from, 90% efficacy rate of those products to 40 to 20% efficacy. So the whole plant really does make a difference compared to lab trials. So, and we found the same thing in Canada where we found that really like 1 to 3 times the label rate of success only really suppresses the parvispinus. And that you really have to go up to like 10 times the rate, which is obviously off-label rates, and I'm not recommending that, but that is the rate that works in experiments. So the pesticides we're focusing on are Pylon, M52, Contos, and Ramon. And we're trying to save avid for two-spotted spider mite and just getting rid of the spinosids at this point. So what I'm telling growers currently is in early production, at the end of propagation, before potting up, you really want to do a sprench of Contos, and this is to get at the parvi larvae. And we've really figured out that early intervention of larvae right after prop is key to preventing these outbreaks early in production. And I've kind of split this up into things you should definitely do on the top of this calendar to things to try or do if needed. So things I would encourage you to try could potentially be experiment with sprenches of M52 at this stage and continue with carpocapsy drenches in early propagation until like the canopy gets too closed up and you can't effectively get them through as a drench. Just moving forward though, potentially in the future, if we don't do the Contos drench, potentially we could double dip the rooted cuttings. So we've dipped the cuttings unrooted when they came in. We could dip them again. And then Vineland is currently experimenting with what products you can do a dip on with that don't affect the roots. Because obviously if you're putting the whole plug tray in, it's every part of the plant's getting the dip. So they're working on that in terms of efficacy and phytotoxicity and like making sure it grows out of it successfully. And then you could add things like M52 and anistis in propagation if you don't have a pesticide like Contos in there. So that, you can go in a bunch of different directions. Then the other thing we're focusing on is reducing costs by making sure the other pesticides you're using for other pests in your program are also targeting parvi. Because it doesn't make sense to me if you've got parvi in your greenhouse somewhere. If you've got oleander aphid in your mandevilla, for example, you wouldn't want to do altus or belief for control of those because those don't affect parvi at all. So what makes more sense to me is to do Contos or Rycar for oleander aphid because we know it works for them, and both of those products have some efficacy on parvispinus as well. And then we also want to make sure we're trying to do something for two-spotted spider mite. So MET52 at higher rates, so around 4 ml per liter, actually can knock back two-spotted spider mite. But it also works well for parvispinus. It works better, or it can work at a lower rate, more like 2 ml per liter. We could also attempt to add in persimilis in the spring. We won't be able to do that earlier in production because it's too close to the fall cleanup. And so for the fall cleanup, I'm recommending pylon, 2 applications 5 to 7 days apart, and doing this right before the temperatures drop. Uh, because what we've noticed is if we clean it up in the fall and then bring the mandevilla down to 15 or 18 degrees Celsius, those low temperatures plus the pesticide knockback gave us anywhere from 12 to 14-week control. So we're really not spraying chemicals then until sort of like late February, early March. And what also can help is removing the flowers because we know we can't get good contact of chemicals on the mandevilla flowers, and we don't need flowers yet because they're not being sold. So we've had the growers bag up those flowers and throw them out, and that's almost like doing a third spray. I feel like the efficacy is the same as doing a third spray. And then later on in production, you would want to do like starting in the spring when temperatures start to warm up again. We're recommending GrowON, which is an insect growth regulator which acts against larvae. And then again, that MET 52 and do that on all the plants and then clean up later in the spring. And then if you do have little problem areas arise, whether it's aphids or parvi or both, that's where you get your Conto spray back out or maybe pylon a certain number of plants. Um, and you might be thinking, geez, Sarah, like that's a lot of repeat sprays of pylon. Aren't we going to hit resistance? Or like, we don't have success in here. Like, shouldn't we have that just for rotation purposes? Well, in terms of resistance management, the timing of your sprays or how you spray is actually more important than what you spray in a lot of ways. So first of all, don't spray if you don't have pressure. So a lot of this is going to depend on your monitoring. And then the Insecticide Resistance Action Committee, or IRAC, has also come up with this like handy dandy little chart showing that really what will screw you up in terms of resistance is they don't want you to spray the same mode of action in sequential windows. So for example, this number 1 or A row, they say this is not recommended, and it's because they've done the green mode of action X, twice in a row, both in the first window and the second window. So what is a window? It's basically a generation time of the pest. And obviously the generation time depends on the temperature. For parvi, it's roughly 12 days at 30 degrees Celsius, but could be more like 21 days at 19 degrees Celsius. So within that one window, if you look at row D, within one window, you can do multiple applications of the same mode of action. You just can't repeat it in other windows. So just looking back at our mapped out IPM program, you can see that, yes, we've got pylon in October, but then we are buffering it in the next generations with some Rimon and M52, and then we're not doing pylon again until the spring. So that's, first of all, those windows are really far apart, and second of all, we are using another chemical in between. And then you notice that in this program, I've also mentioned that if you do get, pockets where you have a parvispinus outbreak, that's where you want to do either Contos or pylon sprays in those problem varieties only. And the reason for that is we found that the spot sprays really also help us with resistance management. We know that with parvispinus, pressure varies a lot by not just crop species, but variety and also source and the size of the planting, like bigger plants that come in earlier tend to be more infested. So you really want to focus on spraying these varieties because it saves the big guns for where and when you need them. And this reduces the chance of resistance because it leaves susceptible thrips in the population. So you can spray the rest of your crop with something softer if you notice an outbreak, say in your 11-inch baskets. Spray those 11-inch baskets with like Contos or Pylon or something, and then do the rest of the greenhouse with M52 or Rimon or something like that. So you get rid of that problem area and it doesn't spill over, but you're not wasting those big guns everywhere else. And the other reason I want to mention spot spraying is just simply for costs. We only have 3 adulticides, meaning adults that work on or chemicals that work on adult parvispinus, which are Success, Pylon, and M52. And remember, Success is kind of out because the rates you need are crazy. So I know I'm running low on time, but just in case you needed some convincing that spot sprays are working for us, these are different programs that we ran on-farm testing when parvispinus first came out, and it was a lot of chemical rotation with using really high rates of success and avid, because we were just like, at this point, we're just going to try everything. We're going to experiment with pesticides and rates, things like that. So when it first came out and we were spraying the whole zone every time we sprayed, In one compartment, if we did an early pesticide intervention, we were spending around 830 $830 of pesticides per 10,000 square feet. And then in a program where we tried to do soft stuff first and then go to hard, so start with microbials and then go to pesticides, but still spraying every plant and every compartment every time, this program was $2,000 per 10,000 square feet. But so when we looked into like how do we come up with a program that's cheaper but has the same quality but also stays within legal label rates and maximum applications, we came up with this strategic spot spraying idea. Um, and basically by doing that and following the little chart that I've showed you in the last few slides, we only spent $378 per 10,000 square feet this year. So if that doesn't convince you that spot spraying works in a commercial situation, I don't know what would. So just quickly to go over where we're going from here, along with dips for propagation material, we're also investigating cold temperatures. And that's because they've got lots of benefits like no REI, no PPE, you just need a cooler. And some preliminary data showed that cold temperatures of under 6 degrees for a few days could reduce them. So we wanted to see if we could go further with that. So right now, the lab trials at Vineland have shown that if you hold your cuttings at 4.8 degrees Celsius for 72 hours, you get a 71% reduction in egg hatch of parvispinus eggs embedded in the leaf tissue. And we're going to see if we can bring this down even more because a 48-hour treatment at colder might actually be better in terms of logistics, like how long they spend in the cooler, but also kill more eggs and larvae. And then growers were really worried about this cooling of the cuttings affecting things like rooting or flowering. So we did those trials. This is work that OMAFA did on farm with a grower collaborator. Cooling to 3 degrees Celsius did not affect rooting much at all. The worst case scenario, some of the cuttings had to be held back for an extra week, but that wasn't a big deal to the grower. And really the only damage we saw was when the cooler dipped below 1 degrees for long periods of time. And that's just because our coolers were not terribly reliable because they were just portable coolers. And then obviously the proof is in the pudding at the end, right? Like when you go to look at the plants and have they flowered and have they trellised properly, and they were, and I can say for certainty that all the trial plants held at 3 or 4 degrees Celsius were as good as their home control that wasn't treated with cold, because when I went back to do the final assessment of number of flowers, all the plants were gone, which means they sold. So that means the grower was happy. The other thing we're going to look at is potentially trap plants. We've used eggplant and hibiscus to not only trap off whitefly, but it also seems pretty attractive to parvispinus. And eggplants are like easy to grow from seed. You can scout them really easily because of the giant leaves and they're relatively low cost and they can just be bagged up and thrown out. And then we're also curious about combining this with something else that's attractive like a lure. And this is work done with plant products. Thank you, Megan. We're continuing this trial with a grower collaborator, but we started off testing a lure, and you can see it's much more attractive than just a normal blue sticky card that's put up. And these dark blue sticky cards are far more attractive than other colors of sticky cards. But the lure is catching, basically increasing our catches by like 100%. So we're going to test that in mandevilla and other like moderately susceptible crops. These initial tests were done in Schefflera. And then I want to just sort of leave you with some thoughts of whether or not mites can find a place. I know I sort of slagged on them a bit in this talk, but I do think some trials that I've seen with Swirsky and Lamonicus in anthuriums in the Netherlands have looked promising. I've also been working with one grower who anecdotally had some good success with Lamonicus and Croton, able to keep the parvispinus levels like suppressed, although they didn't really weren't getting control till they added aureus. So I do think mites have a place, especially in moderately susceptible crops. We're just going to have to figure out what leaves they like and whether they need supplemental feeding or not to see if this is going to be something that's worth doing or just too expensive. So I would say the take-home message is really right now, stay the course with pesticides. We know they work, but everything else is sort of just a big question mark right now. I would feel comfortable adding in nematodes and some microbials like M52 and maybe some soil-dwelling predators like Stratiolaelaps, Scimatus, but everything else is going to be pesticides. And like I said, there's a lot of research being conducted out there. We're almost there. Like in the next year or two, I think we're going to have really robust programs for parvispinus. So just, keep your critical thinking pants on when this information starts to come out, and always feel free to ask me what I think of it. And don't be afraid to do research on your own farm. So I'm also just the last thing I'm going to do before I'm done is just draw your attention, if you're in Canada, to the Scientific Research and Experimental Development Tax Incentives, also called SHRED grants, where basically you can do on-farm trials and get part of that, like the labor and space and plants and supplies and all that, written off as a tax credit. So that's a great way to start playing around with Parvi biocontrol programs. So this is a blog post on the blog, but also feel free to ask me or Catherine about that. And with that, I just want to thank all the summer students that have been involved, all the companies that have donated or collaborated, and all the growers that have put us up with all of us not having any answers at the beginning more than they did, and being able to experiment in their greenhouses with their $1 million crops. So, and with that, I will stop sharing my screen.
Perfect. Awesome. Thanks, Sarah. A lot of good information. I especially liked the close-up face of the nematode.
Doesn't everyone?
Absolutely
Yeah.
horrifying. We do have about 5 minutes for questions. So if you do have a question, please drop it in the Q&A function. We have one so far. What application interval would be recommended if using M52 or S carpocapsae?
I think studies at the Violin Research Station have showed that nematodes really should be put on weekly. They don't last that long in the soil. So I would do weekly for that. And with M52, it's up to economics does play a factor. Like some growers are doing it 2 times a week, and some growers are doing it weekly, and some growers are doing it every 2 weeks. Um, if you want to do it weekly, like I said, you can potentially do a lower rate. Like maybe you want to do it weekly at 1 mil or 2 mils instead of every 2 weeks at 3 mils. So play around and just see what your tolerance is for um, what you can sort of handle. I don't think we have great ideas about what rates are truly effective right now, which is maybe why I'm being wishy-washy about it. I'm a big fan of always trying, different rates and spray schedules in different rows or houses if you can handle that. So play around with it and use, sticky cards to monitor, or plant taps or damage metrics to sort of assess which of those is better. Yeah, and someone piped up in the chat and said weekly apps of M52 are a good place to start. And I'm sort of in the more is better approach right now. But yeah, sometimes I know cost-wise that can be a lot to ask for growers. But I guess I'd rather you would do weekly and lower the rate a little bit than do it every 2 weeks.
And a very related question. Can you tank mix carpocapsae with M52? And my addition to that is, would you recommend that?
So tank mix are technically not allowed in Canada. So official answer is no. But I have done research on the survival of nematodes with different products like pesticides, and nematodes are pretty indestructible, so you can tank mix them theoretically with a lot of things. And I know there was concerns about I think the oil formulations when they first came out, but I do think they are compatible as long as you are agitating and spraying them on right away. I would be more comfortable with them with a wettable powder formation or formulation. But yes, technically you could. But you always want to test your nematodes to make sure they're still alive at the end. So after you spray, you can just put like a little petri dish out when you're doing your application, and then you can check those under, or like a little Tupperware container, and then you can check that under a microscope to make sure things are moving, just to make sure.
A couple more questions here. Have you tried using sticky traps to limit Parvy's population? We've had some exciting results with white-colored, round-shaped traps in mandevilla and hibiscus grown in the greenhouse.
That's exciting. I love to hear a good sticky story. I
This
am
is this is from Greece, by the way. This is a
Oh,
question from
ooh,
Greece.
even more
Yeah.
exciting. Yes. So I totally agree. Um, Judy and I both separately doing trap experiments have found that you get anywhere from like 15 to 30% control using just the traps alone, but it really depends on the crop. sometimes parvi, I almost think of them like Bemisia whitefly as kind of their closest like analogous pest, where sometimes those Bemisia just do not want to come off those poinsettia, so using traps isn't going to work. So we found the dark blue cards seem to work best in tropicals here in Ontario. And I don't like to recommend specific products, but we like the blue cards are different than the yellow, and then the shades of blue within each company are different. So the Russell blue cards seem to work the best right now because they're like the darkest blue. Um, some other people have found good results with white, and I found good results with one greenhouse with the blue in the winter and yellow in the summer. So the caveat with sticky cards is always that their attractiveness depends on light quality. Like because it's about reflection off the card, right? So a different latitude, like Greece versus Ontario, different colors might be attractive. Like I know Copert also did some really great trials with different colored sticky cards, I believe in Spain, and they found the dark green ones to work the best. So you really have to play with color in your own greenhouse in your own location, but it's really easy to just like stick some cards up and in a week see how much more Parvy you have out. But I do think they should be part of a program.
Mhm. Okay. And one last question here. Um, if you're looking for parvy hotspots, can you comment on scouting?
Yeah, so I feel like I have too many thoughts on scouting.
Yeah.
So we started off at the beginning, in this commercial Mandevilla greenhouse, like tapping each variety and walking through and looking at damage to try to get a sense of which the more susceptible varieties were. And that was a lot of labor up front. But then once we sort of knew that, then we were able in consecutive years to go back to those varieties and use them sort of as indicator plants and like focus our scouting efforts on those. So I think when plants are little and you can pick them up and tap them, tapping is always better than sticky cards for actually monitoring levels because even though sticky cards can be useful for mass trapping, they're absolutely not telling you what's out there. Um, the best way to look at them for them is plant washes, and I actually have a video on how to do plant washes on that on floriculture YouTube page under the how-to videos. But tapping is sort of in between cards and the gold standard of plant washes. So when they're little, tap them, get a good sense of which varieties are the most thripsy and also look at damage. And then when the plants get bigger, then you start have to going by more um like damage metrics and vibes. So Parvy's one of those pests where you have to walk the crop every week. Do not sleep on it because like one really sunny day or one warm day and they'll go like gangbusters. So
Mhm. Yeah, they're a bad one. Okay, I don't see any other questions in the chat here. Oh, I have one. Do we have time for one more question,
yeah,
Sarah?
let's do one more.
Yeah, okay. Is eggplant more attractive than peppers?
In my preliminary experiments, they seem to be, but I wouldn't swear to that yet. That's another trial that I'm doing with Vineland soon because the peppers I tried were chili peppers, but they were really young plants and I think we also did it in winter and like the volatiles don't move as well in the winter. So we've had more luck with the eggplant, but only in hibiscus. So we need to find a trap plant that can pull them off those really attractive plants like flowering Lysianthus or flowering Mandevilla. And I don't think we're there yet. I'm going to try the eggplant. Um, I was literally thinking last night, oh, well, you could just buy bouquets of Lysianthus and put them out. And those would be great trap plants and probably cheaper than growing them yourself, as long as they came in clean. But who knows? I think we're just in the early stages of that. So again, play around with it in your own greenhouse if you've got the inclination. Alyssum does work really well. Alyssum, I skipped over that slide because I was like, I'm talking too much. But Alyssum is like 2 to 7 times more attractive than Mandevilla. But the problem is Alyssum has all those little flowers and all those little leaves, and A, it's hard to monitor and it's hard to spray, and it's just and it ended up breeding the parvy. So unless you're willing to like throw them out and replace them every 2 weeks, they can end up being a source for you instead of a sink. So just be aware of that as well whenever you're trying different trap plants.
Okay, I don't see any other questions trickling in here. So I think we'll end it there.
That's great. So when we close the webinar, there will be a survey that will pop up asking how you found the information presented in this webinar and what maybe other topics you want to see and grow on. So please take 2 minutes just to answer that. It's only 5 questions, I think. So, and that would help us out a lot. And with that, everyone have a wonderful week.